In May 1945, a black submarine waited at Horten, Norway. Its war had ended before it could fire a torpedo in combat, yet U-251 was about to begin the most consequential part of its career. The men examining it did not see an ordinary surrendered U-boat. They saw a vessel built around a different idea of submarine warfare. Most wartime submarines were essentially surface ships with an emergency ability to dive. They traveled fastest under diesel power and surfaced regularly to recharge their batteries. Their hulls, gun platforms, and control arrangements reflected that pattern. U-2513 belonged to the Type XXI class. Its designers had reversed the old priorities. The hull was streamlined for movement beneath the sea, not performance on its surface. 3 large battery groups supplied far more underwater power than earlier German boats carried. A snorkel allowed the diesel engines to breathe while the submarine remained mostly concealed. Electric motors could drive it underwater at speeds that transformed the geometry of pursuit. For the German Navy, this was an attempted answer to disaster. Allied aircraft, radar, escort carriers, direction-finding, and coordinated hunter-killer groups had made surfacing increasingly dangerous. A conventional U-boat needed the surface to recover its strength. Every recharge created another opportunity for detection and attack. The Type 21 tried to break that cycle. It was designed to spend far more time beneath the water and escape at unprecedented submerged speed. But Germany constructed this advanced submarine through a deeply troubled production system. Sections were manufactured separately, transported between factories, and assembled under growing Allied pressure. Misaligned components, deficient workmanship, bombing, shortages, and rushed training delayed operational readiness. Germany commissioned more than 100 Type 21s. Only a handful were considered ready for combat when the European war ended. Just one departed on what could be regarded as an operational patrol. None sank an Allied ship. That failure created a tempting but misleading conclusion. The Type 21 had not altered the Battle of the Atlantic. Therefore, it could be dismissed as another German weapon that arrived too late. The United States Navy did not make that mistake. American officers separated the submarine's production failures from the idea inside its hull. They wanted to determine what worked, what failed, and what a competent Navy could reproduce. That distinction would give U-2513 its second life, after surrendering in Norway. The boat was moved with other German submarines to Lisahalli in Northern Ireland. Most surrendered U-boats faced destruction under the Allied disposal program. Their military value had expired, and the victors had no intention of preserving a large German undersea fleet. U-2513 escaped that immediate fate because it was selected for evaluation in August 1945. It crossed the Atlantic as an American war prize. Its destination was not a museum, it was a working naval base. Engineers would inspect its machinery, measure its performance, and compare its design with American fleet submarines. Crews would have to operate unfamiliar German controls and maintain equipment built under collapsing wartime conditions. The boat that had missed its own war was becoming an instrument for preparing the next one. The timing mattered. The United States possessed a huge submarine fleet shaped by Pacific operations. Those boats had achieved extraordinary results against Japanese shipping, but their basic design still belonged to the surface-oriented submarine tradition. They were efficient, long-range raiders that could dive. U-2513 suggested that the future belonged to vessels that lived underwater. This was more than a contest between two hull shapes, a faster submerged submarine compressed detection time. It could change depth, evade escorts, and reposition before attackers completed their calculations. Radar dominance above the sea would matter less against a target reluctant to expose itself. Existing anti-submarine tactics would face a boat designed around avoiding the surface altogether. American officers therefore inherited both a captured machine and a new problem. If the Type 21 concept could be copied, other navies could copy it too. The Soviet Union was shifting from wartime partner to strategic rival. German submarine specialists, components, and technical records were being divided among the victorious powers. No one could assume that the underwater revolution would remain locked inside one surrendered hull. U-251 would soon be repaired, altered, and driven through American trials. Its strengths would inspire changes across an existing fleet. Its weaknesses would reveal why battery power alone could not complete the revolution. And after teaching those lessons, the submarine itself would be used to test the weapons intended to destroy its descendants. The Atlantic crossing immediately exposed the difference between an idea and a reliable warship. U-2513 developed mechanical trouble before reaching the United States. Its German machinery demanded specialist knowledge, while documentation was incomplete and sometimes contradicted the vessel itself. Keeping the prize operational would require reconstruction as much as translation. The submarine reached New London, Connecticut in August 1945 there. American personnel began learning systems designed under unfamiliar standards and assembled during Germany's industrial collapse. Labels, gauges, electrical arrangements, and maintenance procedures all had to be interpreted. Captured German specialists helped explain equipment that American crews had never operated. Their presence did not turn the boat into a dependable machine overnight. U-2513 carried the defects of its hurried construction into American service. But those defects also helped engineers distinguish sound principles from poor execution. The Navy was not deciding whether to reproduce the boat exactly. It was dismantling the design intellectually. Portsmouth Naval Shipyard received orders to study surrendered German submarine types systematically. Specialists examined hull structures, batteries, motors, ventilation, fire control, damage control, living arrangements, and auxiliary machinery. They compared individual German solutions with established American practice. Their reports were often critical. Some systems were ingenious, while others were inaccessible, fragile, or unsuitable for American operating standards. That mixed verdict was essential. Post-war mythology would later portray the Type 21 as a nearly perfect submarine frustrated only by timing. American examination revealed something more useful and less romantic. The boat contained a powerful new operational concept inside an unfinished and frequently troublesome product. Its streamlined exterior reduced underwater resistance. Much of the clutter associated with surface combat had been removed or enclosed. The conning tower fairwater was shaped to produce less drag than the prominent structures on older submarines. The hull still carried compromises, but its priorities were unmistakable. Everything important pointed below the surface. The electrical plant supplied the most visible difference. Earlier German submarines used fewer battery cells and treated submerged movement as a limited condition. The Type 21 carried 3 battery groups with twice the cell count of comparable older installations. That stored energy could support higher speed or longer endurance, depending on how commanders used it. There was no free performance. High speed consumed the batteries rapidly. At economical speed, however, the boat could remain submerged far longer than conventional wartime submarines. The snorkel extended that pattern, with only a narrow mast exposed. The diesels could run and recharge the batteries while the pressure hull remained underwater. The submarine was not invisible. Radar could sometimes detect a snorkel, and aircraft could attack a contact before it disappeared. Rough seas could also close the intake valve, forcing the engines to draw air from inside the boat. Pressure changes, diesel fumes, and machinery noise made snorkel operation punishing for crews. Even so, the tactical equation had changed. An attacker could no longer depend on finding a submarine cruising openly on the surface. The boat's problems were equally instructive. American inspectors found limited access to machinery and weaker damage control provisions than they preferred. Some equipment suffered from corrosion or seawater contamination. Maintenance could become difficult inside tightly packed compartments. German manuals did not always match the boats that had actually emerged from scattered assembly yards. This inconsistency reflected a production program forced forward before its methods were mature. The Navy could reject those weaknesses without rejecting the underlying design. That was the mechanism through which U-2513 began influencing a far larger system. Engineers observed the vessel. Technical findings moved through shipyards, bureaus, and submarine commands. Designers selected useful principles instead of copying the entire boat. American fleet submarines could then be rebuilt around greater underwater performance. Before that program expanded. However, the captured submarine needed to prove that its promise survived outside a drawing office. U-2513 underwent an extensive overhaul during 1946. Its anti-aircraft guns were removed, and changes made it more suitable for American trials. In August, the United States Navy placed the former German boat in commission. Its crew was no longer studying a motionless artifact. They could now take the Type 21 to sea, submerge it, measure it, and discover what happened when theory met American operating practice. Those trials would confirm the boat's most disruptive advantage. They would also reveal the limit that no amount of streamlining could overcome. U-2513 began operating from Key West in late September 1946. Its assignment combined design evaluation with the development of submarine and anti-submarine tactics. The same vessel could play hunter during one exercise and quarry during another. That dual role revealed why its capture mattered. American submariners tested how quickly the boat could maneuver beneath the surface. They examined its behavior at depth, its endurance at different speeds, and its ability to operate through the snorkel. Surface ships and aircraft also needed experience against a target that behaved unlike older wartime submarines. The most dramatic result was its submerged speed. A conventional American fleet submarine could make roughly 9 knots underwater for a limited period. The Type 21 could reach about 16 knots under favorable conditions. That difference was not merely 7 additional marks on a dial. It altered the time available to everyone involved in an attack. A submarine moving slowly after detection remained near the position where an escort expected to find it. Sonar operators could refine the contact while the attacking ship approached. Depth charges or ahead-thrown weapons could then be placed around a predicted point. A faster boat made every estimate expire sooner. During the attacker's turn, approach, and final calculation, the submarine traveled farther from its last known position. It could force sonar ships into sharper maneuvers and exploit disturbances in their detection pattern. An escort built to prosecute a slow target could find itself chasing an expanding area of uncertainty. Speed also allowed the submarine to create opportunities rather than merely escape danger. It could close a target from a less favorable starting position. It could move ahead of a convoy's track or withdraw after firing. The commander gained choices that wartime battery limits had often denied. Yet the tests also confirmed a severe boundary. The batteries contained a finite quantity of energy. Maximum speed consumed that reserve with astonishing appetite. A Type 21 could sprint underwater. But it could not sustain that sprint across an ocean. Sooner or later, the diesels had to recharge the cells. The snorkel reduced exposure, but it did not eliminate noise, exhaust, vibration, or the possibility of radar detection. This was the paradox inside U-2513. It showed what a true submarine should do while demonstrating why existing power plants could not do it indefinitely. The Navy now had 2 connected problems. First, it needed to improve its own submarines without waiting for an entirely new generation. Second, it needed weapons and tactics capable of defeating similar boats operated by a potential enemy. The captured vessel supplied a physical standard for both efforts. It was faster and more elusive than the targets used to validate wartime methods. If an aircraft, destroyer, sonar, or experimental weapon could succeed against U-2513, the result carried greater meaning. If it failed, the failure arrived before an adversary could expose it in combat. The boat consequently became more than a source of German components. It was a moving representation of the threat American planners expected to face in November 1946. That representation received an extraordinary passenger. President Harry Truman boarded U-2513 at Key West with members of his party. The captured submarine proceeded to sea and made a dive to approximately 450 feet. Truman watched a demonstration of the boat and its snorkel system. He became only the second serving American president to travel submerged in a submarine. The event offered useful publicity, but its deeper meaning was institutional. A German vessel that had never completed a combat patrol was now demonstrating the future to the American commander-in-chief. Its cramped compartments still reflected wartime Germany. Its instruments and controls remained foreign. Its batteries would eventually wear out, and many of its fittings would never satisfy American standards. But U-2513 had already made the central problem visible. The United States owned hundreds of successful wartime submarines. Most were now hydrodynamically and tactically outdated. Replacing all of them immediately was financially impossible during rapid post-war demobilization. Leaving them unchanged would preserve a fleet optimized for a war that had ended. The practical answer was reinvention. American engineers would take existing fleet boats, remove features that created underwater drag, enlarge their battery capacity, and equip them for sustained snorkel operations. The captured Type 21 would not be reproduced bolt for bolt. Its operational logic would be translated into American hulls. That translation became the Greater Underwater Propulsion Power Program. Its name was shortened to 4 letters, GUPPY. The GUPPY program treated the wartime fleet submarine as raw material. American naval architects did not need to invent an entirely new hull before gaining better underwater performance. They could remove resistance, add stored energy, and reorganize existing boats around submerged operations. The first conversions would test how far that logic could be pushed. U.S. Odax was selected in September 1946. She belonged to the Tench class, an improved descendant of the submarines that had fought across the Pacific. Her original shape displayed the assumptions of that war: a broad deck, prominent fairwater, deck weapons, rails, masts, and exposed fittings served life on the surface, underwater. Those same features produced turbulence and drag. Workers at Portsmouth stripped away much of that surface-oriented structure. Guns and their platforms disappeared. The bridge and shears were enclosed within a smoother sail. Protrusions were reduced, openings fared over, and the superstructure reshaped. The result looked less like a raiding ship capable of diving and more like a vessel meant to remain submerged. Streamlining addressed only one side of the equation. Odax also received far greater battery capacity. More electrical storage allowed higher underwater speed and longer periods away from the surface. Together, the smoother hull and enlarged batteries reproduced the Type XXI's central relationship. One modification reduced the energy required to move, the other increased the energy available. U.S. Pomodon received a related conversion on the Pacific coast. By 1947, both boats were demonstrating that captured principles could be transferred into American construction. They were not replicas of U-2513. Their pressure hulls, machinery arrangements, safety practices, and operating culture remained American. That difference defined the entire program. The Navy selected mechanisms rather than nationality. Useful features survived evaluation. Unreliable or unsuitable ones were discarded. Early GUPPY boats still lacked the complete endurance solution. Large batteries could extend submerged operations, but charging them remained necessary. Later conversions therefore added snorkels and refined the sail, sensors, ventilation, and control arrangements. Different GUPPY variants emerged as cost, available space, and operational requirements changed. Some received 4 high-capacity batteries. Others used less expensive arrangements that preserved more internal volume. Several retained or later gained improved sonar and fire control equipment. The program became a family of compromises rather than one fixed design. That flexibility allowed modernization to spread. A Navy facing shrinking post-war budgets could rebuild proven hulls instead of discarding them all. The conversion yards already understood American fleet submarines. Crews already knew their fundamental systems. Training, spare parts, and support infrastructure did not have to begin from nothing. The Type 21 concept could therefore enter service faster than an entirely foreign design ever could. Between 1946 and 1960, 50 American submarines received GUPPY conversions. Other fleet boats underwent related snorkel modernizations. The numerical effect was far larger than the 2 captured German submarines that inspired detailed evaluation. A single experimental object had activated an industrial process. U-2513 supplied operating evidence. Naval engineers translated that evidence into specifications. Shipyards converted existing hulls. Operational forces then used those boats to develop new tactics and train new generations of submariners. The changes reached beyond American service. Modernized submarines were eventually transferred to Allied navies. Boats built for the final phase of the Pacific War served for decades in NATO and partner fleets. Their post-war silhouettes carried a visible inheritance from the German submarine that had failed to enter battle on time. Yet GUPPY was not simply a triumph of technological borrowing. It was also an emergency bridge. Even the best battery submarine remained tied to periodic charging. A snorkel made that process less visible, but the diesel engines still consumed air and expelled gases. The mast could be detected. The machinery generated noise, weather affected operations, and the crew endured uncomfortable pressure changes when the intake head valve closed. A submarine could behave more like a true underwater vessel, but only until its batteries demanded attention. U-2513 had exposed the destination without providing the final means of reaching it. Continuous high-speed submerged operation required an energy source that did not depend on atmospheric oxygen. American researchers explored several possibilities. Closed-cycle engines promised underwater endurance, but introduced complex fuels and engineering risks. Nuclear power offered something more radical. A reactor could produce heat without drawing air from above the surface. That heat could drive turbines and generate electricity for as long as the crew's supplies permitted. The streamlined. Underwater first logic demonstrated by Type 21 could finally escape the limits of battery endurance. GUPPY preserved American strength during the transition. Its converted boats trained crews. tested sensors, tracked opponents, and served through the early Cold War, but another lineage was already forming behind them. The lessons of U-2513 would meet nuclear propulsion, creating a submarine that no longer needed a snorkel at all. U-2513 influenced American strategy in two opposite directions. It showed naval architects how to build submarines that were harder to find and attack. At the same time, it showed anti-submarine forces how quickly their wartime advantage could disappear. The first lesson produced GUPPY. The second created anxiety throughout the Navy. During early post-war exercises, Type XXI submarines proved extremely difficult for American escorts to contain. Their speed disrupted attack patterns developed against slower wartime boats. Their snorkels sharply reduced the opportunities available to radar-equipped aircraft. A mature enemy fleet using these characteristics could reopen the Atlantic problem the Allies had only recently solved. The feared fleet belonged to the Soviet Union. Germany's surrender had scattered submarine technology among the victorious powers. The Soviets obtained several Type 21 boats, as well as German technical material, equipment, shipyard resources, and specialists. American planners lacked a clear picture of how quickly Moscow could exploit them. That uncertainty encouraged worst-case estimates. The Soviet Union might manufacture large numbers of submarines combining German underwater performance with its own industrial capacity. If war began in Europe, American troops, fuel, weapons, and aircraft would again cross the Atlantic. A sufficiently powerful submarine campaign could attack those reinforcement routes. The strategic consequence of U-2513 therefore extended far beyond submarine design. It helped redefine the problem confronting escorts, aircraft, sonar laboratories, and naval planners. The Navy needed better targets to develop better defenses. U-25 served that purpose from Key West. Surface ships practiced detecting and tracking it. Aircraft worked against a submarine with less need to expose its complete hull. Experimental weapons could be evaluated against a target that moved at more realistic post-war speeds. Later, American high-speed submarines continued this demanding role. The Hunter had become the model for its own countermeasure. The perceived Soviet Type 21 threat was partly exaggerated. The Soviet Union did absorb German ideas, but it did not simply mass-produce exact copies of the captured design. Its post-war submarines followed several developmental paths shaped by Soviet requirements and engineering choices. Western intelligence initially possessed too little evidence to make that distinction confidently. Plans had to account for what Moscow might build, not merely what it had already deployed. That gap between known capability and feared capability accelerated American action. The new Tang class represented a more deliberate response than conversion. Instead of rebuilding a wartime fleet boat, designers could arrange a submarine around post-war priorities from the beginning. Tang incorporated greater battery power, underwater streamlining, a snorkel, and improved performance. It was an American design, but its purpose reflected the standard the Type 21 had established. It aimed to improve upon the captured German concept rather than preserve the older balance between surface and submerged operation. Anti-submarine warfare changed with it. A submarine could itself become an effective hunter of other submarines. Operating quietly beneath the surface, it provided a stable platform for passive sonar. It could wait near likely transit routes and attack an opponent before that opponent reached the open Atlantic. This emerging mission differed from the commerce war fought by American submarines in the Pacific. The target was no longer primarily a freighter, tanker, or naval auxiliary. It was another submarine. The transformation affected the surface and air forces as well. Hunter-killer groups returned in new forms. Escort carriers and specialized aircraft practiced coordinated searches. Sonar development received renewed attention. Later, fixed underwater listening systems would extend detection across vast ocean areas. The chain that began with one captured hull now reached laboratories, fleet exercises, alliance planning, and ocean surveillance. Nuclear propulsion completed another portion of that chain. The reactor did not emerge from U-2513, and the German boat should not receive credit for inventing nuclear submarines. American nuclear development followed its own scientific, political, and engineering history. But the Type 21 had demonstrated the operational value of sustained underwater performance. Nuclear power removed the greatest limitation revealed during its trials. Nautilus could generate propulsion without surfacing or raising a snorkel to obtain oxygen for diesel engines. It combined independent American reactor technology with the underwater first direction already proven necessary. Nautilus retained a hull form that still reflected earlier submarine construction. Later experiments, especially U.S. Albacore, would develop a more efficient teardrop shape for submerged movement. Those streams eventually converged. Nuclear power supplied endurance. Hydrodynamic research supplied the hull. Advanced sonar supplied awareness. New weapons supplied reach. The modern attack submarine emerged from that synthesis. Not from one captured vessel alone. U-2513's importance was narrower, but still profound. It made the transition unavoidable by operating the boat rather than merely studying its plans. The Navy encountered a future opponent in physical form. Every failed sonar approach and every exhausted German battery clarified the next requirement. The Type 21 showed where submarine warfare was going. American institutions decided how to travel the remaining distance. After the presidential demonstration, U-2513 returned to less visible but more important work for 6 months. It supported evaluation and tactical development from Key West. In March 1947, the submarine headed north to Portsmouth, New Hampshire. Its movements now linked the operating fleet directly with the shipyards studying its design. U-2513 remained at Portsmouth until September. It then conducted 6 weeks of operations from Portsmouth and New London under the Atlantic Fleet Submarine Command. These waters offered experienced submariners, research facilities, and surface forces that needed exposure to faster submerged targets. By October, the boat was back at Key West. For nearly 2 more years, it resumed the cycle of trials. Exercises, maintenance, and tactical development. This was the repetitive labor through which a captured object became useful knowledge. Not every voyage produced a dramatic discovery. Crews accumulated performance data across changing conditions. Sonar teams learned how the boat sounded from different angles and at different speeds. Surface units practiced maintaining contact while it maneuvered beneath them. Engineers observed which systems deteriorated and which features remained reliable under sustained use. U-2513 also worked beside its American counterpart, U-308. The United States had received both boats for evaluation. Their American modifications were not identical. U-308 received a smaller, more streamlined sail, while U-2513 retained more of its original external form. Comparing them helped reveal the effect of alterations without requiring an entirely new submarine. The pair became laboratories that could move, dive, and resist the forces testing them. Their usefulness, nevertheless, depended on equipment that could not last indefinitely. The batteries were the heart of the Type 21 concept. They were also consumable industrial products with finite service lives. Repeated charging and discharging gradually reduced their capacity. Heat, corrosion, maintenance demands, and age continued working even after the war had stopped. Replacing the German installation would have required substantial expense. By then, American GUPPY conversions were already providing modernized domestic test platforms. New submarine designs were advancing. The unique value of keeping U-2513 operational was shrinking. Its declining battery represented the same limitation the boat had exposed from the beginning. The Type 21 could carry more electrical energy than an older submarine. It could not escape the chemistry on which that energy depended. In the summer of 1949, U-2513 left Key West for the last time under its own operational assignment. It traveled north through Norfolk to Portsmouth there on July 8th. It was placed out of service. The German batteries had reached the end of their useful life. A submarine built to reveal the future was immobilized by the oldest constraint in its design. Deactivation did not immediately determine its final fate. U-2513 remained at Portsmouth for approximately 2 years. Preservation was possible in theory, but naval priorities made it unlikely. Maintaining a foreign submarine required space, money, technical knowledge, and continued protection against deterioration. Museums also needed an institution willing to receive and display a vessel more than 250 feet long. The historical importance, obvious in hindsight, competed with immediate military requirements. The Navy had already extracted plans, measurements, reports, and operating experience. GUPPY submarines were in service. The Tang class was entering the post-war fleet. Nuclear propulsion was moving from proposal toward construction. To planners, U-2513 had become redundant hardware. Its remaining value lay in destruction. The Navy was developing weapons capable of attacking fast submarines before they escaped a sonar contact. Traditional depth charges fell behind the attacking ship and covered an area with explosive pressure. Head-thrown weapons allowed an escort to attack, while its sonar still held the target. Wartime systems such as Hedgehog had demonstrated that principle. The post-war threat demanded heavier, faster, and more effective successors. One of them was an anti-submarine rocket system known as Weapon Alpha. It projected a large explosive charge ahead of the attacking ship. A sonar team would detect the submarine and provide the contact information. Fire control equipment would process range and bearing. The launcher would then send the projectile toward a calculated impact point. The mechanism mirrored the challenge U-2513 had created. A faster target reduced the time between detection and escape. The weapon had to move the explosive effect forward before that opportunity closed. In August 1951, the deactivated submarine was towed south toward Key West. On September 2nd, the Chief of Naval Operations ordered its destruction. The Type 21 had taught the Navy how future submarines might survive. Now it would help test how they could be killed. In early October 1951, U-2513 reached the waters west of Key West. The submarine had no operational crew aboard. It was now a controlled target, positioned for an experiment designed around the threat it represented. U.S. Robert A. Owens approached with the weapon meant to defeat that threat. The destroyer was itself a product of the transition after World War II. Originally conceived during the war, it had been completed and configured for specialized anti-submarine duties. Its sensors, fire control equipment, and forward-projecting weapons belonged to a contest moving beneath the ocean's surface. The attacking ship first needed information. Sonar energy traveled through the water and returned from the submarine's hull. Operators interpreted the contact and supplied range and bearing. The fire control system converted those changing measurements into an aiming solution. Only then could the launcher act. Weapon Alpha sent its explosive projectile forward toward the calculated position. This sequence was the counter mechanism to the Type 21. Detection alone was not enough. A report had to move from sensor to operator, from operator to calculation, and from calculation to a weapon quickly enough. The submarine's speed made every delay more dangerous. On October 7th, rockets from Robert A. Owens struck the target. The captured boat that had survived, hurried construction, surrender, an Atlantic transfer, years of testing, and exhausted batteries finally went down. It settled in deep water near the dry Tortugas. No wartime destroyer had hunted it. No convoy escort had forced it beneath the surface. Its only fatal attack came from the Navy that had preserved it for study. That ending can look like simple waste. U-2513 was one of very few surviving examples of the Type 21 class. It had carried a serving president beneath the sea. It had contributed to one of the most important transformations in modern submarine design. Today, such a vessel would appear to be an obvious museum candidate. In 1951, the decision looked different. The Navy was maintaining a vast quantity of surplus wartime equipment. Ships competed for berths, maintenance funds, crews, and institutional attention. Foreign machinery without a continuing operational role imposed additional costs. Preservation standards for large 20th-century warships were still developing. The Type 21's technical value seemed safely captured in drawings, reports, photographs, and American conversions. The hull appeared less valuable than one final destructive experiment. There was also no sentimental American service history attached to U-2513. It had not carried a United States crew into battle. It had not saved a convoy or returned from a celebrated patrol. It remained a weapon built for Nazi Germany, even after American sailors learned to operate it. Preservation, therefore, lost to utility. The decision placed U-2513 among many advanced wartime machines destroyed after their secrets had been extracted. Aircraft were scrapped after flight evaluation. Tanks were cut apart after ballistic tests. Ships were sunk by gunfire, torpedoes, rockets, or atomic experiments. The victors did not preserve the defeated arsenals as a complete historical collection. They selected samples, retained documents, and disposed of the rest. Most surrendered German U-boats met an even faster end. During Operation Deadlight, British forces towed scores into the North Atlantic for destruction. Some sank before reaching the designated areas because their material condition was already poor. Others were destroyed by naval gunfire or explosives. Only a small group escaped long enough for specialized evaluation. U-2513 received 6 additional years because its design posed unanswered questions. Those years mattered more than its lack of combat. A submarine can influence history by sinking ships. This one influenced history by repeatedly refusing to behave like the targets expected by its captors. Its speed challenged sonar teams. Its snorkel challenged aircraft. Its batteries challenged engineers. Its unreliable construction challenged admirers who confused innovation with perfection. Its final destruction challenged a new weapon to complete the entire detection and attack chain. The wreck remains on the seabed west of the Florida Keys. Its depth and remote position make it far less accessible than a museum vessel. Corrosion and marine growth continue altering the structure. The pressure hull that once embodied a feared future has become an underwater archaeological object. But the boat did not vanish when it sank. Its components had already been measured. Its behavior had already been recorded. Its central principles were already moving through American shipyards. The physical U-2513 went to the bottom. Its operating logic remained afloat. The influence of U-2513 must be stated carefully. It did not single-handedly create the American post-war submarine fleet. The United States had already developed capable submarines. Strong shipyards, advanced sonar research, and an expanding nuclear program. British, German, American, and other naval experiments had all contributed to the underwater revolution. The Type 21 was one decisive piece of evidence within that larger process. Its importance came from timing and physical proof. American engineers did not encounter only captured drawings or optimistic German performance claims. They operated an actual boat. They experienced its speed, observed its snorkel, measured its machinery, and discovered its weaknesses. The result was neither worship nor dismissal. It was selective reinvention. Streamlining and increased battery capacity entered the GUPPY program. 50 American submarines received GUPPY conversions between 1946 and 1960. Related modernizations carried the underwater first principle into still more wartime hulls. The Tang class pursued the same direction in a purpose-built American submarine. Experimental Albacore demonstrated a radically improved submerged hull form. Nautilus removed the need for atmospheric oxygen as a source of propulsion. Those developments eventually converged into the modern nuclear attack submarine. The opposing system changed as well. Fast submarines demanded improved sonar, forward-thrown weapons, specialized aircraft, quieter hunting platforms, and new operational doctrine. They encouraged surveillance networks designed to find submarines across ocean basins. The boat tested at Key West therefore affected both sides of the engagement. It helped shape the submarine and the machinery built to destroy one. None of this erases the system that produced it. Type 21 construction belonged to the final phase of Nazi Germany's war economy. That economy depended heavily on coercion, forced labor, concentration camp prisoners, and lethal working conditions. The class should not be celebrated as an isolated masterpiece detached from those human costs. Its rushed modular production also generated serious defects. Innovation did not cancel exploitation. Poor quality control, or strategic failure. Nor did the submarine arrive close to reversing Germany's defeat. Allied control of the air and sea, the destruction of German industry. Fuel shortages, incomplete training, and collapsing transport networks restricted the class before it could become operational in numbers. A technically threatening concept was not the same as a functioning combat system. This distinction explains both halves of U-2513's story. Germany possessed the concept but could not regenerate the industrial, logistical, and training network required to deploy it effectively. The United States captured one example and connected it to intact shipyards, research institutions, trained crews, operational commands, and substantial resources. The difference was not a mysterious quality hidden in German steel. It was the system surrounding the object. In May 1945, U-2513 waited at Horten without a combat record. Its crew surrendered a submarine built for a campaign that never came. 6 years later, the same hull rested on the seabed after an American rocket test. Measured only by ships sunk, its career amounted to nothing, measured by the decisions it activated. Its post-war life was far more significant. It forced engineers to separate a revolutionary idea from a defective production program. It gave submariners direct experience with an underwater first opponent. It helped justify rebuilding wartime boats while new propulsion systems matured. It became a target for the tactics and weapons created in response to its own capabilities. That is why the final image is not merely a wreck near the dry Tortugas. It is a chain of reinvention. A German battery boat became an American test vessel. The test vessel became a design reference. The reference became converted submarines, new classes. new sensors, and new anti-submarine weapons. Then the original object was destroyed because the system no longer needed it. The Type 21 had arrived too late for Germany's war. U-2513 arrived at exactly the right moment for America's post-war fleet. If you value documented stories about what happened after the fighting ended, subscribe for the next episode.